We live in a universe of stunning beauty. Throughout human history, people have wondered, why does this breathtaking universe exist? Why is the cosmos here? Why are we here? Has the universe always existed, or did it have a beginning? And if it did have a beginning, was a creator involved? Or did the universe somehow form all by itself? The Bible says that the Lord created the universe for His own purposes and His own glory. It describes a creation event that no human was around to see, but if there were humans on Earth back then, they would have seen this creation occur just a few thousand years ago. But this is not what many scientists believe today. The majority view today among secular scientists is that our universe formed itself in a Big Bang event about 13.8 billion years ago. In this video, we'll examine the Big Bang model to see whether or not this model actually fits the universe we live in. We'll discover that in spite of the opinions of secular scientists, the Bible is by far the superior explanation for our created universe. I'm Spike your host. This is the third volume of the What You Aren't Being Told About Astronomy series, and it's about the biggest topic of all. The Big Bang model is a theory of everything. It's supposed to explain where the entire universe came from. And since the universe contains everything that can ever be perceptible to us, the Big Bang model, therefore, is supposed to explain why everything exists. But just how good is this model? In this video, we'll look at the Big Bang model. We'll see that it's not as good of a theory as you've been told. We'll see a lot of evidence that is inconsistent with the Big Bang, but quite consistent with the biblical description of the heavens instead. The Big Bang is a very popular idea today. There are even many Christians who believe that God used the Big Bang to create the universe. They do this because they've been told that the Big Bang is good science. But as you'll see in this video, the Big Bang is actually not good science, and Christians are under no obligation to accept it. Nevertheless, there are some Christians who believe that God created the universe in some sort of Big Bang event. This belief is misguided, and I've written more about this at creationastronomy.com. For now, keep in mind that in this video, when I talk about the Big Bang, I'm talking about the secular idea that the universe created itself in the Big Bang with no creator being involved. In previous volumes of this video series, we looked at the secular explanation for the origins of our universe. We saw that supposedly, the universe is about 13.7 to 13.8 billion years old. Supposedly, in the beginning, there was nothing. And then suddenly, there was something. The universe burst into existence in an event now known as the Big Bang. At first, the universe was filled with radiation, and then as it expanded and cooled, matter began to form as gas. This gas was about 3/4 hydrogen and 1/4 helium, with maybe trace amounts of lithium and beryllium, but nothing else. As time progressed, this gas started to clump together to become the first stars. These stars clumped together to become the first galaxies. As billions of years passed, other stars and galaxies formed. One of them was our own Milky Way. Within the Milky Way, a smaller cloud of gas collapsed, which formed our solar system. And within the solar system is the planet Earth, where we are today. In the first volume of this series, we looked at the origins of our solar system. We saw that this part of the model has many major problems, as it can't account for many of the solar system's characteristics. Indeed, it says that many of the planets shouldn't exist at all. In the second volume, we looked at earlier stages of the model, the formation of stars and galaxies. Again, we saw that the secular model actually can't explain the contents of the universe, because it has no way to account for the formation of the first generation of stars. In this volume, we're going all the way back to the beginning and examine the Big Bang itself. We'll see if this part of the model is any better than the later parts. We'll dig deep into the scientific literature and talk about things that few non-cosmologists know about. Also, this video will be about the creation of the universe, but obviously there aren't any photographs of this event to look at while we're talking about it. So for most of this video, we'll see lots of pictures of the contents of the universe today instead, some of the most beautiful objects that God has made. So here's what we'll do in this video. First, we'll look at the Big Bang model, and we'll examine the evidence that is offered to support it. We'll discuss why secular scientists claim that this theory is good science. Then we'll look at several reasons why the Big Bang is actually bad science. It turns out that a closer look at the evidence actually discredits the Big Bang instead of supporting it. After that, we'll go even further and look at the full implications of the Big Bang model. We'll see that not only is the Big Bang not good science, It's not even bad science. It's actually anti-science. When taken to its logical conclusion, the Big Bang model makes science itself impossible. So if science is a valid way to discover how the universe works, then the Big Bang model must be false. Now that's a pretty bold statement. So let's get started. When we look out into the universe, it's easy to wonder, why is it here? The Bible says that the universe is here because God created it, as described in the first verses of Genesis. In the beginning, God created the heavens and the earth. The Bible describes how the creation occurred over 6 days. The earth was created first, and then on day 4, the sun, moon, and stars were created. Of course, this explanation for the universe is not the one you'll hear endorsed in science programs, textbooks, and so on. In fact, in our society today, we're often told that it's illegitimate to try and use the Bible to understand the history of the universe, because the biblical account of creation is supernatural. The prefix super means above or beyond. Therefore, something that is supernatural is that which is above or beyond the natural world. And many scientists today insist that only natural explanations are allowed in science. Now, previous generations of scientists didn't think this way. In fact, most of the giants of science, great scientists like Kepler, Newton, Euler, Pasteur, Faraday, Maxwell, and many others, all believed strongly in the Bible and in the biblical account of creation. They saw no problem doing science with the biblical outlook. Nevertheless, the reigning outlook in science today is naturalism, the idea that only natural explanations are allowed. For example, the University of California at Berkeley has a website called Understanding Science that explains it this way. Modern science does not deal with supernatural explanations because they are not scientifically testable. In other words, there's no way to gather evidence that would help us determine whether or not the explanations are accurate. We're told that the biblical account of creation doesn't meet this standard, and so it's disqualified. In fact, we're told that we don't need the creation account anyway, because we have a natural explanation for the universe, the Big Bang model. And we're told that this explanation is based on good science. But is it really? Let's take a look. The Big Bang model is based on 3 primary lines of evidence: redshifted light from faraway objects, the abundance of light elements in the universe, in other words, the amount of hydrogen, helium, and lithium that exists, and finally, the cosmic microwave background. Now, some of those concepts might be unfamiliar to you, so let's go through them briefly. When we look out into space, outside of our Milky Way galaxy, we see lots of other galaxies, and we've discovered something very strange about these galaxies. Except for a small number of galaxies that are fairly close to us, all the rest emit light that is redshifted. And it appears that the farther away they are, the more redshifted their light is. Here's what it means for light to be redshifted. You're probably familiar with the idea that if you take a beam of white light and shine it through a prism, the prism will break up the light into the various colors that it contains. Astronomers have instruments called spectroscopes or spectrometers that do similar things. When you analyze sunlight with one of these instruments, you'll see a pattern that looks like this. Notice that sunlight contains a wide spectrum of wavelengths or colors, all the way from red to violet, all the colors that the human eye can see. But notice also that in a few places, there are some specific colors missing. These are called absorption lines. What's happening here is that the sunlight has to pass through the sun's atmosphere on its way to us, and certain elements within the sun's atmosphere absorb specific colors as the light passes through. So those colors are missing from the sunlight. It turns out that each element absorbs its own set of colors. So by looking at the set of absorption lines within sunlight, we can actually measure which elements are within the sun's atmosphere. When we look at sunlight, we see a spectral pattern that looks like this. But here's a second spectral pattern from a distant galaxy. Notice anything about it? You can see that the elements in the sun's atmosphere make a distinctive pattern of spectral lines. You can also see roughly the same pattern in the light from the distant galaxy. So that tells us that the stars in that galaxy are made up of roughly the same elements that the sun is. But notice also that the patterns don't line up exactly. The spectral lines from the distant galaxy are shifted toward the red end of the spectrum. This is called a redshift. Light gets redshifted when the object that's emitting the light moves away from the observer. You can think of it as the light waves getting stretched out. On the other hand, light can also be blue shifted when the object emitting the light moves toward the observer. You can think of it as the light waves getting bunched up as they travel. We see then that we can measure starlight from distant galaxies and see if it's redshifted or blue shifted. If it's blue shifted, the galaxy is moving toward us. If it's redshifted, the galaxy is moving away. And it turns out that except for a few close-by galaxies that are blue-shifted, every other distant galaxy we can see is red-shifted. In other words, except for a few close neighbors, every other galaxy we see is moving away from us. And it appears that the farther out a galaxy is, the more red-shifted its light is. In other words, the more distant galaxies are moving away from us faster than the ones that are closer. This discovery was a real surprise. There are several possible ways to interpret it, but secular astronomers choose an interpretation that's now called the cosmological principle, or sometimes the Copernican principle. This idea says that any observers in the universe would see the same things from their perspective as we see from ours. In other words, no matter which galaxy you happen to be in, you would see all the others rushing away from you, just like we see from our vantage point in the Milky Way. Now imagine what this means. If all the galaxies are moving away from each other, then the universe is expanding, and it's getting bigger as time goes on. The opposite is also true. If galaxies are moving farther away as time goes on, this means that they used to be closer together in the past. If you can mentally run the movie backwards, you'll see that eventually you reach a time when all the matter in the universe was at the same place. And this idea is the basis of the Big Bang model. The Big Bang model basically says that all the matter, all the physical stuff in the universe, started out compressed into an extremely tiny point in space. And not just the matter was compressed, the entire universe, all of space itself, was compressed into a single point. Then it suddenly exploded outwards, and that outward motion continues until this day, although the rate has changed somewhat over time. This is supposedly why we see all the galaxies still moving away from each other today, because space itself is still expanding, and carrying all the galaxies along with it. And this is the first of the three main lines of evidence that are thought to support the Big Bang model. Red-shifted light from faraway galaxies would indicate that they're all moving away from us as time goes on. And if you mentally run the movie backwards, you can imagine that everything started out at the same place, which was the Big Bang. The second line of evidence comes from the amount of light elements, hydrogen, helium, and lithium, in the universe. Secular astronomers have tweaked the Big Bang model to a point where it can supposedly account for these elements in the same concentrations that we see today. The third line of evidence is based on a prediction made back in the 1940s and 1950s. Back then, a few astronomers had realized that if the Big Bang were true, we should see leftover low-temperature radiation from it. Radiation matching this description was found in 1964, and it turns out that there's microwave radiation coming to Earth from all directions in space. This is now known as the CMB, or the cosmic microwave background. This radiation is at almost exactly the same temperature everywhere, regardless of the direction it's coming from. This sky map shows the temperature variations, which are tiny. The color differences represent variations of less than 1,000th of a degree. We'll see later why this is important. Anyway, the discovery of the CMB was the crowning glory of the Big Bang model. Other secular cosmologies of the time were quickly abandoned, and the Big Bang became the dominant model among secular astronomers. After all, the model not only matched the known evidence, cosmic redshifts, and the abundance of light elements, it also made a prediction that was then supported by later observations. Most secular astronomers today believe that this proves the Big Bang model to be correct. But there's more to the story than this, much more. Let's move on to our discussion about why the Big Bang isn't actually a good scientific model after all. To assess the validity of the Big Bang model, we need to examine it in a little more detail. Let's start at the beginning. The Big Bang theory says that in the beginning, there was nothing. Then it exploded. What exploded? Nothing exploded. How can nothing explode? Big Bang believers explain that nothing can explode and does. In fact, nothing did explode and made everything. That's why there's everything instead of nothing, because nothing exploded and created everything. There, see how easy that is? Of course, saying that nothing created everything doesn't work. Nothing can create nothing. Nothing can do nothing. From nothing, nothing comes. As R.C. Sproul once said, if there was ever a time when there was truly nothing, there could never be anything. And as Dr. Phil Fernandez once said, you can't tell me that nothing made everything. I know too much about nothing. If you ask a secular cosmologist about this, some will just shrug and say that the question of what existed before the Big Bang is meaningless, because time itself didn't exist before the Big Bang. So we can't ask about conditions before the Big Bang, because there was no before the Big Bang. There was no then. As a Harvard astrophysicist explained, What came before the Big Bang might well be a meaningless puzzle, since at the beginning of the universe, matter, energy, space, and time probably all came into being. The concept of time before the Big Bang is quite possibly nonsense. To most cosmologists, asking what happened prior to the Big Bang is akin to asking what lies north of the North Pole. In other words, we aren't allowed to ask how the Big Bang could have happened, because it just did. The Big Bang happened because it happened. And since there was nothing that could have created the universe just created itself because it created itself. That's not good reasoning though. Something can't create itself, because in order for the something to do anything, it must first exist. Self-creation would mean that the universe would have to exist before it existed, which is obvious nonsense. Sometimes you'll hear people say that yes, the Big Bang was extremely improbable, but if you wait long enough, even events that are extremely improbable will eventually occur. Well, that doesn't work either for two reasons. Number one, self-creation isn't improbable, it's impossible. It doesn't matter how long you wait, the impossible still won't happen. Number two, even if it were just improbable, it still doesn't work, because the Big Bang model says that time didn't exist before the Big Bang. So you can't wait long enough for an improbable Big Bang to happen, because you can't wait at all. There was no time within which to wait, nor was there a place to wait. Despite all this, some cosmologists still try to justify the Big Bang anyway. For example, famous astrophysicist Stephen Hawking has claimed that gravity is responsible for the Big Bang. Quote, "Because there is a law like gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist." He explained further, "The laws of gravity and quantum theory allow universes to appear spontaneously from nothing." Notice how he said universes in the plural. We'll talk more about that later. For now, notice what Professor Hawking is saying here. He's saying that the laws of physics are responsible for the universe creating itself. Is this a good explanation? No, for several reasons. First of all, the laws of physics don't actually allow universes to create themselves. We'll talk more about this in a moment. Second, the idea doesn't even make sense. What is a law of physics anyway? What does a law of physics look like? What does it sound like? What does it feel like when you hold one in your hand? Obviously, these are all ridiculous questions. The laws of physics are not physical things. So what are they then? Laws of physics are patterns that we've observed about how the universe works. For example, if an object is held above the Earth and then released, it will fall, and it will do that over and over again each time you repeat the experiment. Because it does this consistently, we can measure how it happens and then describe it mathematically, as Isaac Newton did when he first wrote down his formula for gravitation. But again, this formula is not a physical thing. It can't create anything because it's merely our description of how the universe works. It's merely our description of the universe's pattern of behavior. Now let's apply this to the Big Bang model. According to this model, before the Big Bang, the universe didn't exist. Well, if the universe didn't exist yet, then its patterns of behavior didn't exist yet either. So they couldn't have been involved in the universe's creation. And so, secular cosmologists are still left with no way for the universe to create itself from nothing. And so, to avoid this, many cosmologists are now redefining the meaning of the word nothing. Secular cosmologists will still insist that the universe was created from nothing by nobody. They even write books about it. But when you dig a little deeper, you discover that when they say nothing, they sometimes don't mean nothing. Some cosmologists claim that before the Big Bang, there was a quantum vacuum field that fluctuated, and it made a particle pop into existence, which then grew explosively and became our universe. But there's a problem here, which you might have noticed. If the Big Bang was a fluctuation in a quantum vacuum field in space, then the universe didn't really come from nothing. It came from a quantum vacuum field, and a quantum vacuum field is not nothing. Even many secular scientists have complained about this inconsistency. As one physicist has said, a more fundamental problem is that this scenario does not really explain the origin of the universe. The quantum fluctuation of the vacuum assumes that there was a vacuum of some pre-existing space, and we now know that vacuum is very different from nothing. Vacuum, or empty space, has energy and tension. It can bend and warp, so it is unquestionably something. And famed cosmologist Alan Guth wrote, "From the point of view of general relativity, empty space is unambiguously something. According to general relativity, space is not a passive background, but instead a flexible medium that can bend, twist, and flex. A proposal that the universe was created from empty space seems no more fundamental than a proposal that the universe was spawned by a piece of rubber. It might be true, but one would still want to ask where the piece of rubber came from. So all that's happening here is secular cosmologists are just substituting one problem for another. To explain the universe, cosmologists are invoking a pre-existing quantum field. But they offer no explanation for the quantum field itself, or where it came from, or why it would even obey laws of physics from a universe that didn't even exist yet. So they say the universe came from nothing, but when they say nothing, they actually mean something, without explaining where this nothing that is really something came from. Some cosmologists try to cover this problem up. For example, Lawrence Krauss in his book Universe from Nothing tries to justify the nothing that is really something by claiming that a quantum theory of gravity is responsible for the universe creating itself. Notice that Stephen Hawking did the same thing earlier, when he also said that quantum gravity allows the universe to create itself. But there's a serious problem here, which they aren't telling you about. Physicists don't actually have any good theories of quantum gravity. A valid theory of quantum gravity does not exist. And these scientists are fully aware of this fact. As Krauss himself admitted in an interview, I also don't have a quantum theory of gravity, so I can't tell you for certain how space comes into existence. So even though some cosmologists claim that the laws and theories of physics would allow our universe to create itself, this claim is false, as they themselves admit. In addition to not actually being allowed by physics, the Big Bang model goes much farther and also violates some of the most important laws of physics. Probably the most fundamental idea in physics is that energy and matter are conserved. In other words, energy and matter cannot be created nor destroyed. Physicists have known for some time now that energy and matter are interchangeable. For example, you've probably heard of Einstein's famous equation E equals mc squared. The E stands for energy, m stands for mass, which is the amount of matter or physical stuff, and c is the speed of light, which is a very large number. So a lot of energy is contained within a small amount of stuff. And we can convert matter to energy. The most efficient way we know how to do this is in a nuclear explosion. A small amount of stuff releases a tremendous amount of energy. We can also go the other way and convert a lot of energy into a small amount of stuff. We do this in particle accelerators. Tiny particles get accelerated to almost the speed of light and then get smashed together. More material comes out of those collisions than went in. The particles' kinetic energy, the energy contained in their motion, gets converted into matter. So again, we can convert matter to energy and energy to matter, but we can never destroy either one, and we can never create either one. This is called the law of conservation of mass energy, because the total combined amount of mass and energy in the universe never changes. We can only convert them back and forth. This law is one of the fundamental, foundational laws of science. As one of my physics textbooks says, conservation laws are the guiding principles of physics. These are absolute conservation laws. They are always obeyed. We see this law's effects every day in our lives. Why do you need to eat food? Regardless of how difficult that task may sometimes be. Because your body can't create energy from nothing, so it needs to get it from the chemical energy stored in the food. Why do you need to pump gas into your car? Because your car can't create kinetic energy, the energy of motion, from nothing, so it needs to get it from the chemical energy stored on the gasoline. Why do you get a bill from the electric company every month? Because the electrical devices in your home can't create energy from nothing, so they have to get it from the electric company, which also can't create it from nothing. It gets it from coal or natural gas or some other source. In fact, you couldn't be watching this video if this law weren't true, because you're watching it on an electronic device. And some of the principles of electronic circuit design are based on this law. Again, this law is very fundamental, but the Big Bang model violates it on the largest possible scale, a universal scale. It says all the energy and matter contained in the entire universe was created from nothing. Therefore, the Big Bang contradicts physics in the most fundamental way possible. Are cosmologists aware of this problem? Yes. Some try to avoid it by claiming that the universe actually consists of balanced amounts of positive and negative energy, which all add up to zero. In other words, even though the universe looks like something, it's actually just nothing. Therefore, they say, On a net basis, the Big Bang didn't really create anything, so there's no problem with physics being violated. This claim is false though. This idea doesn't work. So the Big Bang continues to violate physics in the most fundamental way and on the largest possible scale. Now let's move on and discuss not one, not two, but three major predictions made by the Big Bang model that have failed. As the original Big Bang model was developed, cosmologists realized that there are some important ways in which the model doesn't match the universe. For one thing, the Big Bang should have produced massive numbers of magnetic monopoles, magnetic particles with only one pole. These particles should fill the universe, but not a single magnetic monopole has ever been found. Another problem, called the horizon problem, was discovered when astronomers started getting better data on the cosmic microwave background. To make a long story short, if the Big Bang had happened, then the CMB should contain large-scale temperature irregularities. But these irregularities aren't there. As I said earlier, the temperature differences in the CMB are minuscule. And yet another problem was discovered in the geometry of space. The Big Bang should have produced a universe with either massive positive